You just learned how to use substitution to solve systems. There's another method called elimination that is sometimes easier depending on how the equations look. In this case, the x's and the y's are on one side of the equation and the numbers are on the other. And there's this magical method that's super cool. If you add them together, what happens to your y's? They disappear. That's the elimination part. And if I add my x's, I get 2x. The y's are gone. 6 and 2 gives you 8. I divide by 2. I get x is 4. I then just plug that 4 back in and get 4 plus y is 6, and y is equal to 2. And I like to write those as an ordered pair, so I get 4, 2 as the solution to the system. It's the one point that makes both equations true. Both equations have an infinite number of solutions, and you just found the one they have in common. Shockingly, they're not always that easy, where they're lined up and the variables cross off. So I want to change this equation so that the variables do cross off, that they get eliminated. So we can either get rid of the x's or the y's, it doesn't matter which. I'm going to choose to get rid of the x's. So if I want to make a 2x disappear, I'm going to multiply this entire equation by -2. When I do that, I have to multiply every single term by -2. Otherwise, I change the meaning of the question. So I end up with -2x minus 8y equals 2. And I'm going to add it to that first equation. And we know we did it right because we have it set up so that one of the variables is going to be eliminated. So when I add these together, the x's disappear. I get -9y equals 9. Divide by -9, and I get y is -1. Going to plug that back in. It doesn't matter which equation you plug it into, but I end up with 2x plus 1 is 7. 2x is 6, so x is 3. So my final solution is 3, -1. If you want to double check to make sure you're right, plug it into your second equation. 3 plus 4 times -1 is -4. That equals -1. You know you're right. It's nice to be able to do a little double checking. So go ahead and pause your computer and go ahead and do this question. All right. Did you get -2 1/2? If yes, great. If not, pause the video and see if you can find your error by looking at my work. I chose to eliminate the y's and solve for x first. But again, you could have done it another way. And then the last thing that can happen is, what if I can't multiply one equation by something to eliminate a variable? Well, it means I need to multiply both equations by something. I'm going to choose to eliminate my x's. So I'm going to turn my x's into one of them into a +6 and one of them into a -6. Since 2 and 3 both go into 6, I have found a number I can aim for. So if I multiply this by a +3, then I have to multiply this one by a -2 to make the x's disappear. I could have done -3 in the top equation and +2 in the bottom if I wanted. So when I do this, I get 6x minus 15y is 9, and -6x minus 4y is -28. Add them together, I get -19y equals -19, so y is 1. And then I just do my substitution. Plug it into the first equation or the second, whichever one you want, and solve. And I get 2x minus 5 is 3, 2x is 8, so x is 4. So my final ordered pair is 4, 1. And again, if you want to check it, plug it into the second equation and you would get 12 plus 2 is 14. You know you did it right because if it works in both equations, you found the right answer. So now you go ahead and you try one. Pause your video. If you got 2, 1/3, you got it right. If not, stick around and see if you can find your mistake by following my work here. Hopefully that makes sense. You can head off now and do your homework.